This is from exam 1, problem number 11. It all centered around this graph, and this is one of the things I want you to know most going forward. It's also a rather hefty point problem. If you look at it on this exam, it was a 12-point problem. That's because there's just a lot of little bits of information that you're supposed to know. For instance, you start out with the domain and range. The domain is where the function lives in terms of the x direction. So that starts here at the left and goes here to the right. What you had to be careful of is that over here to the right, that that point was hollow, meaning it's not on there. So technically you should be writing negative 2.97 to 2.97, parenthesis here because you're not including that, bracket here because you're including that. Same thing's going to go for the range. The range goes from lowest to highest, so negative 5 to 5. Negative 5 is not included, positive 5 is included. So parenthesis and bracket respectively. I did give credit for people who regarded negative 5 as being a local maximum, even though it's not even on the graph. I was a little bit more, or a little bit happier for people who included the 5 here, because at least 5 is on the graph. But as far as local mins and local maxes are concerned, mostly what I was looking for was the y coordinate here and the y coordinate here. Local min, local max. Increasing. Well, it starts increasing right here, and I gave you that point on the graph. So it starts increasing from here to here. If you notice that g at 0, it's neither increasing nor decreasing. If you wrote it like this, broke it up, you might notice that you got a bonus point for this answer. But this is mostly what I was expecting, and that's what most people gave me. Likewise, it's decreasing in a couple intervals. It starts decreasing to the left of this point, and it's decreasing again to the right of this point. So those are the intervals where it's decreasing and increasing. A couple other things I could ask about this would be, is this a function? So what do you think? Is this graph a function? Yeah, it passes a vertical line test. Is it a one-to-one function? No, it fails the horizontal line test. How about this? Is it an even function? Ooh. Even functions are symmetric with respect to the y-axis. So y equals x squared is a very simple example of an even function. So lots of problems that I could ask about this. And what I like about it is it doesn't require any calculation. You don't even need decimals or anything like that. It's just straightforward. Do you understand all the various concepts here? All right, so make sure you're comfortable with that one moving forward. Other than that, exam 5 had a few problems that I want to look at with you. In particular, this one, problem number 8. Now, there's a couple ways I can ask this problem. So for instance, the way I asked it here, I first asked you to give me the sequence of partial sums. So S2 is the sum of the first 2 terms, S3 is the sum of the first 3 terms. Some people confuse that with, oh, what's the first term, what's the second term, what's the third term? Whoops. All right. So that was a couple hopefully easier points. The second part of this, you needed to use this formula. And to use that formula, there's one key ingredient that you're kind of missing here. We know the first term and the last term. The first term is 1, the last term is 8,401. But how do you get that this is the 2,101st term? Well, you got to fill in the general form of the equation and then replace that a sub n with 8,401 and then solve for n. That's how I got that this is the 2,101st term. Now there's another way that I could ask this question. I didn't on the exam, but this was exactly what I put forth in the review. So let's take a look at it in a different way. I could give you something like this. The sum from n equals 1 to 2,101 of 4n minus 1 How about 4n minus 3? At 4n minus 3, and ask you to do that. Now, if you were given something like this, what I would hope you do is something that I didn't see too much of on the exam, is that you expand this sum by putting in first n equals 1. 4 times 1 is 4, minus 3 is 1. Next one is a 2. 4 times 2 is 8, minus 3 is 5, and then 9. And then when you get all the way up to 2,101, that's going to be 8,401 again. So, all right, that's the sum that you're trying to find. What you should notice about this, and what you should be able to tell, is that that's a arithmetic sequence. D equals 4. So if I asked it this way, I said, all right, well, what's the sum of that series? You'd just have to find S of 2,101. That's going to be 2,101 over 2 times the first term plus the last term, 8,401. And then, of course, you can do the work from there. Another thing that I would expect from this previous exam is Pascal's triangle. And what I'm trying to do with the problems that I'm highlighting here is emphasize the stuff that you're going to need going forward, the stuff that I think is most important coming out of this course. And I think the ability to, say, raise something to the 4th or 5th power using Pascal's triangle is a good skill. And I wasn't convinced that you guys nailed that one on the last exam, so I'm going to give you another chance at it soon. Beyond that, you've had 2 other reviews online. I think you should be in good shape. Any other quick questions or thoughts before I wrap it up here? All right. Well, good luck, and I hope you do well this Thursday.